Welcome everybody to Njord's live event on vessel performance solutions. My name is Frederik Bind and I'm the managing director of Njord. Njord is a green technology catalyst and we work with ship owners and charters as their green transition partner, accelerating their journey to zero by assessing, designing and installing combined packages of energy efficiency technologies. In Njord, we believe that a combined technical, commercial, and regulatory analysis is required to determine your vessel optimization options. So delivering just that is the essence of the work we do for charters and owners. In Njord, we are passionate about energy efficiency technologies, and we operate independently across brands and suppliers with a growing portfolio of more than 40 technologies. And one of those is the use of vessel performance systems. And that's what we'll talk about in today's live events. So why vessel performance solutions? So in Njord, we categorize energy saving devices or ESDs in two categories: direct saving technologies and enabled savings technologies, where the direct saving technologies can be deployed on a vessel and start delivering savings without further intervention, whereas enabled saving technologies require some kind of continued intervention from shore or offshore personnel. We categorize vessel performance solutions in the latter as an enabled saving technologies. And in this case, in reality, vessel performance solutions or technologies does not deliver any direct savings, like for instance, a dock or a PPCF. However, through a VPS, the level of transparency, the amount of data, the crucial insights on the performance of the vessel or on any of the installed ESDs hold a tremendous value if used correctly. So what are the options out there today? What is required in terms of hardware versus software? How does the different solutions enable other energy efficiency technologies? And what are the good implementation cases of today? In our live event today, we will dive into these questions to get wiser on vessel performance solutions. Remember, as an audience, you are able to post questions anytime during the events. We will try to respond to as many as possible as we run through. So don't wait until the end to post your questions. If you have a specific question already now that you would like to have answered, then feel free to start typing it into the chat. With that being said, it gives me immense pleasure to introduce the panelists of today. We'll start with Ozzy. Ozzy has 10 years of experience working in the shipping industry. In his role as product manager at Napa Shipping Solutions, Ozzy has been championing the use of digital solutions, including voyage optimization and performance monitoring tools, with the target to minimize the carbon footprint of shipping. His past work has been focused on R&D and enhancing energy efficiency through ship system simulations, onboard audits, training, and consultations. And prior to joining Napa, Ozzy was the energy team lead at a ship design company where he supervised the energy efficiency projects and studies for both new builds and existing vessels, and developed data analysis and simulation capabilities. Ozzy has a master's degree in naval architecture and marine engineering from Aalto University, as well as an ongoing MBA studies at Copenhagen Business School. A big welcome to the panel today, Ozzy, and thank you for choosing Copenhagen as the place to study.
Thank you. It's a beautiful city.
Great. Then we'll move on to the next panelist. Next up is Michael. Michael is head of vessel performance within Miros Motion. He is a naval architect with extensive experience with ship design, vessel performance optimization, and testing of energy-saving devices. Together with Miros Motion, Michael is dedicated to the decarbonization of the maritime industry by providing ship owners and charters with accurate vessel performance data to ensure optimal vessel operation and to enable a realistic evaluation of energy-saving measures. And Michael holds a Bachelor of Science in Naval Architecture. Welcome to the event, Michael.
Thank you very much.
Then we have Christian. Christian is the Senior Vice President of Danelec Connect and IoT Business at Danelec. Christian joined Danelec in 2023 and has over 15 years of industry experience in maritime and software sectors, with tenures at IBM, Maersk, and Zero North. Areas of expertise from Christian's side is commercial shipping, software sales, development, and maritime digital transformation. He also has sailing experience, and education-wise, Christian holds a master's degree from Copenhagen Business School and leadership courses from INSEAD, IMD, and Harvard Business School. Welcome to the event, Christian.
Thank you very much.
And then, last but not least, On our call today, we have Sten. Sten is the technical director of Njord. Sten has close to 40 years of experience from Maersk and has been responsible for driving results through innovation in areas of fuel efficiency, new building supervision, and retrofits, amongst others. His key roles have included head of fleet technology, head of cost leadership, and fuel optimization, fairly relevant today, Sten, while also having sailed as chief engineer on all types of Maersk oil and chemical tankers. Welcome to the event, Sten.
Thank you, Frederick.
And with that, a big welcome to all four gents. It's a pleasure to have you. And with that done with, we'll kickstart with our different questions that we would like to go through. Again, remember as an audience, start typing questions so we can paste them into the discussion as we go along. But Sten, I'll start with you. I know that you have been working closely on increasing the performance of the Maersk Tankers fleet. Can you tell us a bit about why is vessel performance solutions relevant today? Why does it matter, and why should we pay attention to it?
Absolutely relevant today as it was back in 2009 when I was tasked to improve the efficiency of our newly acquired Brustok fleet. And fresh out of the vessels after 20 years at sea, I started digging into our MSPS, Maersk Ship Performance System data, and was quite horrified at the data quality I could see. But even though the data quality was quite poor, it was good enough for us to create transparency around the variation between sister vessels and the different segments. And it was actually a fantastic thing to identify this variance, because that means there's a huge potential. And that changed our 3-month scope to a 6-month scope to a 2-year scope to later that's still in active duty today, the fuel performance team at Maersk Product Tankers. So we started working on the low-hanging fruits, and then a very active data quality drive where we were identifying the reasons for the data quality not being so good. And one of the main areas was that the crew was not really able to see what was going on with the data. So since we could show management that there's a huge potential, we were allowed to invest in both analysts, engineers, but also software developments, where one of the most important was our vessel performance onboard analyzer module, where the MSPS data was fed back to the vessels so they could see their own vessel performance, their KPIs, but also the sister vessels performance. So that drove a lot of engagement and improving both efficiency, but also their reporting quality, because those things are very much linked. So it was an amazing journey, and it showed us that we actually achieved in 4 years' time a 20% reduction. And that was, of course, due to optimization of base load and stuff like that, but also the clarity of when are we supposed to clean the hulls. All this transparency again opened up for virtual arrival discussions, arrival on time, super slow steaming, slow steaming. So a lot of operational drives were set in motion on the back end of creating transparency. So transparency is key, and to have transparency, data quality is key. And I'm sure we're going to touch base on that many times today. And remember, all this was based on new reporting. Today, I hope we are going to be talking more about high frequency data, which is definitely, in my point of view, the way forward.
Yeah, I was going to ask you about that for sure, Sten, because I mean, I expect that with the timeline here, when this went down, it was with tools that are not really, well, we're hopefully much more mature today. But that's actually what we'll jump into. I think we'll just put a note in the 20% improvement. That's quite something substantial, and it will be interesting to hear from the different panelists here what they see when there's good utilization of their platforms. But with that, I would love to jump into the different solutions and get a bit more introduction into what we represent today. I'll start with you, Ossie. Please give us an overview of the Napa system and what that represents.
Sure thing, Frederick. Thank you for having me here on this call. So I bet many of you already know Napa from before, but we basically are separating into 3 business units. So design solutions, where we provide software for ship designers, naval architects, shipyards to design and build better ships. And then there's safety solutions, providing electronic logbooks, stability computers, etc. And then finally, shipping solutions, where I'm from, where we do performance analytics and voyage optimization. But in our product called Napa Fleet Intelligence, we are combining the expertise that we have from this domain by creating a holistic tool where we do not only rely on the data that we will be getting from the ship side, but rather combining that knowledge and information with the weather forecasts, AIS data, nautical charts, etc., and bringing it all together in the beating heart of public intelligence, which is our vessel-specific performance models that we have built already for around 60,000 vessels. And that performance model is then the source for weather routing, but also the performance monitoring solutions that we are providing.
Got it. Thanks a lot for that overview and that fly-in, and we'll have the opportunity to deep dive even further. Just a follow-up here. So for the Napa perspective, we're talking an exclusive, you could say, software solution that comes out. There's no hardware in-house, and I guess any requirements to hardware is something that you then hook up the Napa solution to, right?
That is correct. So we are a software company, and when it comes to data, we are data agnostic. So we are more than happy to integrate with any solution provider when it comes to the noon reporting or the high frequency data. But we also have our own in-house built solutions if there are no noon reporting platforms available on board.
It sounds convenient, but also complex. We'll dive into also data accuracy and etc. when we move on to that. But thanks for the introduction, Ossie. We'll move over to Michael from Mirror's Motion to give a similar introduction, please.
Hey, everybody. My name is Michael Schmidt, and I'm heading vessel performance within Mirror's Motion. Mirror's Motion is a data-driven vessel performance system. The core of the Mirror's Motion system is a radar-based technology where we base ocean current, speed through water, and the wave spectrum around the vessel. The measured data is being used in different applications, such as charter party performance, anti-roll assistant, and our vessel technical index. That's our vessel performance application. For this event, we will focus on the vessel performance application. For the vessel performance application, we also connect on board to shaft meter, anemometer, GPS, gyro, rudder angle indicator, in order to capture all relevant data to evaluate the performance of a vessel. And all the collected data is being processed partly on board on an edge computer and is being sent to the cloud so the data can be assessed ashore. Mirror's Motion was part of a DNV research project, which has resulted in the DNV recommended practice for measuring vessel performance. And the vessel performance index in that recommendation is named Vessel Technical Index, and this is why we are using that also. The objective of that research project was to develop a practice for measuring and analyzing vessel performance data. And the overall goal was to reach an accuracy that would enable us to verify, for example, various fuel-saving measures. And today, Mirror's Motion can actually provide this vessel technical index calculation more or less live. We can do it with 2 hours delay. This is our core delivery right now when it comes to vessel performance. Lastly, I will mention that the Mirror's Motion system can also just provide speed through water and wave spectrum for any third-party system, which is using data. We believe that we have very accurate data on speed through water and ocean current and wave spectrum, which other softwares and applications can benefit of. Thank you.
Super. Thanks a lot for that introduction, Michael. And again, so when we talk Mirror's Motion, then no hardware in-house as such, but a connectivity to the different hardware solutions out there today. Right? Okay.
We are connecting to that hardware on board the vessel, but one specific thing is that we need a dedicated X-band radar. Obviously, that is important.
Yeah.
I would say, though, that some vessels, they have a redundant X-band radar, which we can use. For example, larger container ships, they can have a port radar or whatever, and then we can connect to that. Then they have to run that radar at sea, and then we can use that.
Okay, got it. Thanks a lot. Thanks for the introduction, Michael. And I guess it's encouraging to hear for a 2 hours delay only, right? I mean, compared again to the story you shared at the beginning in terms of working with data and implementing corrective measures, etc. Okay, let's jump to Christian. Super keen to hear the introduction from your side as well on Data Lake, please.
Thank you very much, Frederick. Hi, everyone. I'm Christian. I'm representing Data Lake today. And Data Lake, we come from an outset that is slightly different than the two others in the panel today. We are hardware first. We are high-frequency data first. Thereby not said that we are doing anything in software. We are actually doing a lot on that, both on board and also onshore. From Data Lake, we come with almost 40 years of experience in hardware on board vessels. We are best known for our voyage data recorders and then our jet powers that come from our acquisition of Kyma 3 years ago. And in Kyma, we have done vessel performance monitoring for the last 20 years on board and onshore as well. We have some knowledge in that domain. As of today, we have 13,000 installations on board, 13,000 vessels with various equipment on board. We have today around 600 vessels on our vessel performance monitoring solution, where we can, as you can see in the bottom of the page here, we can do fleet performance monitoring, voyage optimization. Then we have fairly good traction in the LNG market, where we have equipment on more than 70% of the fleet for that. And then again, as our two other gentlemen today, we're also doing something on green charter. But yes, we come from a background of hardware, Frederick, and moving into a software. So you could say we're doing a turnkey solution and some moderations around that.
Great. Thanks for the introduction, Christian. In case you didn't mention it, the aggressive move into software bit is definitely also coming from the recent acquisition, right? Maybe we just highlight that in case you didn't do that in the intro.
Yeah, sorry for that. Perhaps I should mention that we have late last year acquired Nautilus Labs, which we are merging into our Data Lake Connect offering this right now. So that is, of course, giving us some more model-based approach with AI and machine learning on top of that. That still comes back to the early point that Sten mentioned as well. It comes back to having good data, right? It comes back to data quality. But we now have modeling expertise and can do digital twin models, etc., around that we couldn't do just 4 or 5 months ago.
Super. Thanks, Christian. And I'll get back to you because you actually started my next question around level of implementation, the widespread of the technologies so far, and maybe also dive into a bit of the results seen for the owners who have decided to install either both hardware or software. But I think I'll just go back to Sten. I mean, reflection from your side, Sten, X amount of years has passed since you moved onshore, started working on performance, the tools you had available back then versus hearing the different solutions that we have represented here on the panel today. What are your reflections?
No, it's amazing. So all three solution providers here have an impressive suite of software solutions that I could only dream about back then. And Michael from Myros Motion having a speed-through water radar with the accuracy that we see there is like the holy grail for performance. It has been a headache for decades in the shipping industry that we were not able to accurately determine the real work the vessel was doing. So we had to spend months of analysis picking up data to compensate for speed-through water measurements. So this is a game changer in the industry, which I hope will be adopted more widely in the future. Definitely, we are going to do our best to include this. It is important. But the machine learning and AI perspectives are also magnificent. So I'm just sitting, clapping my hands. I'm really excited.
That's good. And I think it's important also to mention, I can't think of an owner yet. We have recommended to do some kind of vessel performance solution on the vessels as well, because it's just an enabler for so many things. But then let's talk about implementation. Christian, I'll start with you. You alluded to it before. It's super interesting for us to hear and also for the audience. Where are we when it comes to utilization, both hardware and also then through Nautilus Lab software? And if we can both talk a bit of numbers on utilization, but also some of the good success stories. I mean, what have we seen in terms of results of having implemented these solutions?
Yeah, I think good question. What we're seeing And of course, I'm very biased around that, but we are seeing that more and more people have an interest in getting sensors on board and getting better data quality out to the onshore team, to the operators, in order to create better foundation for the operational insights and driving that. That could also foster some better safety on board. It could give some time back to the crew that they don't have to fill out a number of new reports manually. So we, of course, think that there's a good perspective around that. We have seen some of the biggest, sophisticated companies wanting to have sensors not only on their own vessels, but also on the vessels that they charter in. So they get same view on that, and that makes a lot of sense. That being said, and we know this because we have bear a lot of scars on our baggage, it can be difficult to get things on board vessels. We have 700 certified technicians worldwide that can go on board all major ports in the world and get stuff, but it still needs to be installed. You still need to have the time in port to install it, make sure it works before you pass on. And that can sometimes be tricky. And that's why we're also seeing and testing out whether we can actually create smaller application products that the crew can install themselves and thereby getting same view on board as the operators have on the software platforms.
Super. Thanks. Maybe just to get back to the question, I mean, so when we talk, for instance, also to compare with the software solutions here with the two others, in terms of installations, Nautilus Labs, I mean, how many vessels are there on the platform today?
We have for our software only, we have a little more than 600 vessels as it is today on the ship performance monitoring. And then, of course, we have the shaft power installation, which gives the crew on board insight into the shaft limitations. We saw a big Chapuis wave in the last 2 years with people installing a lot of shaft powers. And I know you had a section as well on that. And that has also given sort of a new mindset, you could say, around some of these. So I suspect more will come.
Okay, super. Interesting element around the, I would say, complexity of installations being time consuming and how to mitigate some of that. I think it's probably also interesting to hold that up against the effect and the performance upside you will see once installed, because I guess that's one of the dilemmas that you will sit with as an owner. But we'll get back to that, Christian. Now, I want to jump to Michael from Miros in terms of the same question. So where are we implementation wise and maybe early stage, some of the results seen from utilization of the system?
I can only say that we have the same challenges as Christian, because we are installing hardware on board ships, and that is challenging. That's no doubt about that. I mean, if we could live only in a software world, that would be much easier. But we have today, I mean, mirrors and the radar technology that has been developed over 30 years for the Norwegian offshore sector. So there, the sort of the radar technology, which is the core of our system, that has been installed basically on platforms and offshore vessels in Norway, and where they have been measuring and verifying current measurements and so on. But when we came into it for the commercial shipping, that is only 3 years ago. And when we developed these applications, we have today installations on 2 large container vessels, 2 tankers, and 7 bulk carriers. And we have actually lately experienced quite an interest, and as Steen alerted to, is the speed through water is really a key, because we have a lot of projects out there at the moment where people are installing fuel-saving measures and devices, and they really have difficulties to identify what is the actual effect. So we see actually quite an interest at the moment. But at the moment, we have 11 systems up and running on various different vessels. And lately, we installed our system on a high-profile wind assisted vessel because they also wanted, what should we say, more accurate data to be able to evaluate the effect of the systems.
Got it. Okay, thanks a lot for that high-profile wind-assisted vessel. I wonder which one that could be. But let's move on. Thanks for that insight, Michael. And speaking of wind, then obviously there's the whole twist of hooking up a vessel performance system to other energy saving devices. I know that that's something in Napa that you've actually done quite some work on, but we'll dive into that as well. Ossie, I would like to get some insights from your side as well on where are we in terms of magnitude when we talk installed systems and currently running systems from Napa's side.
Sure thing. So Napa has quite a long history on vessel performance monitoring and weather routing solutions already from the 90s. And for example, our product called Classic Napa Green has been very successful in providing the value by performing accurate analytics based on high frequency data, many different vessel types. But the latest technology platform called Napa Fleet Intelligence is also providing the monitoring and analytics for the data, both for the high frequency data, which benefits, it's quite universally accepted. It's more accurate, more beneficial to have high frequency data. But of course, it's also a fact that a lot of the industry is still working on the noon report based, especially on the bulk carrier side. So we try to be a data agnostic, accepting both data types. To come back to your question regarding installations, or over 4,000 unique vessels are being monitored currently on the Napa Fleet Intelligence. That divided in slightly different categories and modules that we have there. But to pinpoint one of the modules called Napa Voyage Optimization, been actively used in hundreds of vessels.
So how many, sorry?
Hundreds.
Okay, yes. Okay, got it. Thanks a lot. Thanks for explaining that as well, Ossie. A lot of different things to dive into here. Maybe just one reflection from my side when we go through. One common thing was obviously complexity of installation, but there was also alluded to the fact that you could do with some specific required hardware, and then others could be flexed in terms of whether you need or not. And then I heard also, at least from Christian, but especially also from Ossie's side, that in terms of different platforms, there are different modules to choose from, and there are different, you could say, levels depending on how far reaching you want to go in implementing the different platforms and the different sub elements of the platforms. Steen, from your side, I mean, as an owner, choosing different hardwares when it comes to vessel performance, data collection, transferring, and then different vessel performance systems and different modules. Is this a complex story?
It's very complex. I think one of the key factors here is what are you going to do with all that intelligence that you receive from these? The systems themselves do not necessarily provide the big changes in operation. You need somebody to take action upon the analytics that you receive from these systems. So some companies choose to start a little bit easy, just to get a feel of it and start proving some savings and improvements, and then grow from there and then adopt more and more modules as they go along. And management is convinced to invest in some dedicated resources to create value out of all these insights. That's your performance that we are running is addressing that element and helping ship owners getting value out of these very, very good systems. So it is something the ship owner needs to consider, how big a system do they want? It has to match with the resources they invest into it to get the value back.
Yeah. Okay. Thanks, Steen. And so, in terms of the value, I'm super keen on getting to the gist of the value add that we see here. Christian, I mean, from your side, having, let's say, the 600 vessels on the Nautilus Labs, for instance, but also having put hardware to create this high frequency data transfer, etc. I mean, you must have some kind of insights from the different owners that you worked on in terms of what was the value seen. I mean, in terms of measured savings or improved performance as a consequence of high frequency data or having the Nautilus Labs platform.
Yeah, that's a good question. If I just may start somewhere else and then get to that question, I think
Sure.
we come from a data transportation side, which means that we can use known reports as well. And we can send data also to Napa, for instance, to that platform as well. So we are agnostic in that sense, which means that we have seen many things, we have tried many things, and we know the complexity and the lack of standardization that Steen is also referring to here. And I think it comes back to also the maturity of the company that we're talking about. When now Steen started out mentioning Maersk Tankers and the Broström fleet back in 2009 or whenever it was, and talked about a savings of 20%. Or one of our customers published a paper a few months back stating that they have saved exactly 20%. And that is not only us isolated in Nautilus Labs and in our ship performance solutions that can proclaim that. That's also going in and looking at the propeller design. Is there something you can do here? Are there other things? And therefore, I think it's important that we do not. Of course, I will sit and advocate for our turnkey solution. But I think when we talk about vessel performance and when we talk about this, it cannot be completely isolated to us. We need to work together on various fronts for the benefit of the owners. And then if you are a sophisticated owner, then you have a team that can look at 2,000 data points. If you're a smaller owner, operator, then perhaps 50, 60, less than 100 data points is perhaps sufficient to run the vessel. Again, it's a matter of religion when it comes to those kind of things, I believe. I don't know whether I answered Frederick.
Yeah, you did. I mean, you said a number, and I'm fairly happy with that. We also put some disclaimers to it, but I think it's okay. Then we have something on the table here. And I also alluding to how many data points and how many resources does it require to run. We'll get back to that as well. So that was a good cliffhanger. Michael, the Holy Grail, the speed through water. So, I mean, what do you reckon here? I mean, how's that going to make a difference, and what kind of figures will we be able to save as getting this transparency? But you must have some kind of opinion around that.
I know you are fishing for numbers here, but these numbers are very, very difficult. And I think most of us know that because it always depends on what the head are you comparing against.
Yeah.
And people coming up with very high numbers, you always need to know what they are comparing it against. But I can give you two examples. One example is that we believe that one of the features with our system is to be able to exactly know your fuel consumption, your speed consumption, which can actually be used in softwares like Aussie's Napa system, route guidance, or whatever Christian does in terms of, for example, route optimization. I mean, I can give you one example. Not long ago, we had a vessel loading in multiple ports in South America, and they had only less than 1 day voyage between these ports. And one of these short voyages, we were able to capture a severe fouling that was obtained only in less than 1 day. And therefore, we calculated this VGI. We could identify it with the VGI. And when the vessel was loading in the last port before it was supposed to go across the Pacific, they actually cleaned the propeller. And we could exactly measure what was the effect of that propeller cleaning. That means they had the correct fuel table for optimizing a trans-Pacific voyage. And for that particular case, they only cleaned the propeller. We reduced the consumption by 10% for that voyage. And if you have, for example, a no report-based system, you would never be able to capture a change in performance in less than a day voyage. And therefore, what could have been saved in the voyage optimization by having the correct fuel table? That's very difficult for me to say. And I guess Arctic and Christian can confirm that it is not easy to identify what can you obtain by a voyage optimization. But I can say that if we hadn't cleaned the propeller and the voyage was performed at the same course and same speed, that has cost 10% more fuel.
There we go. No, great. Yeah, see, I push you a bit, but I want to hear numbers. I think it's really good. And I know they come with disclaimers, but I like the storyline here also in terms of it is because of the high frequency data that you capture this. So it's not with a delay and you can actually take some mitigating actions and then improve the performance here. So the answer is accepted from my side. Michael, thanks a lot.
Thank you.
Aussie, I'm keen to hear what are your reflections on here, and do you dare to put some numbers on as well?
Yeah, Frederick, I was expecting this question and I made some notes for myself, and they say it depends. So I'm pretty much on the same line with Christian and Michael here. So it's very hard to define the baseline where you're comparing against. So I cannot promise you a number what you can gain from performance monitoring or weather routing. But again, I can give you a few examples on that. So of course, for weather routing, the payback time is almost instantaneous. You start saving fuel immediately, and the cost of the system versus the fuel saving potential, it's definitely in favor of small or very instantaneous savings and payback times. We've done studies on this with different baselines and definitions and all that. For example, a few years back, we studied a cross-Atlantic voyages from a handful of tankers, and we calculated around 8% better TCE and around 16% lower fuel oil consumption, which was very good results for that. But then also, of course, on the other side, on the short sea shipping, where there is still benefits, but usually much lower single-digit savings, we're talking about usually around 2 to 8% as we've been calculating. Then for the performance monitoring side, I guess as Christian mentioned, it comes also from the increased transparency and situational awareness of having the spatial location against the forecasted weather, etc., or better data management and for regulatory reporting, EU ETS allowance management, CI level forecasting, etc. So it is definitely a very much multi-domain challenge, and it again depends heavily on ship types, operation areas, how the vessel has been operated in before, and all.
Got it. Thanks, Ossi. I'm keen also because I know that you have spent quite some time on this weather routing and combining it up with one of the well-known wind assisted propulsion providers out there in the industry. I mean, is there anything that you can share in terms of the success stories here? I mean, how was the Napa solution able to provide the insights for a vessel with a WASP system on to increase the performance of that system?
Yes. So wind assisted propulsion systems, they are definitely one of the most interesting ESDs out there currently. Installations of those are doubling basically annually current rate. We've studied that quite a lot, for example, with Norse Power, whose office is actually 100 meters from ours. So we're quite good buddies with them. But also with Sumitomo from Japan, we did a research project where we calculated on average 19% fuel savings combined weather routing and broader sails. And from that 90%, 10 percentage points were due to weather routing. So we're definitely encouraging the ship owners who are looking for wind assisted propulsion to also consider combining that with the weather routing.
So an additional 10% upside on the wind assisted propulsion because of the weather routing. Was that what you said?
Yes. So 90% combined.
Okay.
Weather routing and us. And then from that 19%, 10% percentage point was due to weather routing.
Okay.
So if you're considering the investment for those, you can quite easily almost double the savings.
And a super good example. And thanks for sharing that, Austin. And back to your example from before, Michael, on the mirror's motion as well. I mean, the propeller fouling as well. And one of the other technologies we also work with in Njord is also technologies that keeps the propeller from fouling, right? So I guess if this is something that you monitor on a fairly frequent basis, then it will lead to a discussion around should we do something else in terms of keeping the propeller from fouling over a long period of time, either in the next coming dry dock or as an installation on the way. Okay. Super good examples here, Jens. Really good to hear. So we are getting some good questions in on the chat as well. I'll start to bring those up so we can have a chat around and see if we can answer some of the good questions that comes in here. So I'll start by bringing the first one up on the screen. I'll probably jump to you as the first one, Michael, and then take a round to see who else have something to chip in. Avinash asks here, how do you rate and compare AI and machine learning driven models for capturing the performance of vessels compared to traditional method by preparing baseline by sea trial and shop tests? Michael, reflections from your side on this question specifically?
Mm-hmm. Yes. Well, obviously, there are something to gain from AI and machine learning models, no doubt about that. But it all comes down to the correct data. And even these models that are purely data-driven, they require really, really accurate data. And I must say that when we have been out installing our systems, sometimes I'm a little bit horrified with what data there are available on board ships and the quality of that data. And I wonder how these models can capture these or benefit of these. But I would say my belief is that the base performance, I would say traditional sea type subchest data, a more direct methodology, it will work. And this is also what we do with the VTI. But I definitely believe there's a huge gain for AI and machine learning driven model when it comes to applying weather. And actually, I'm more interested in sort of a hybrid methodology where you have a baseline which is driven comparing C-Troid uptake data, and then the weather addition or the weather component is more data-driven, AI-driven, or machine learning-driven. That's my personal belief that a hybrid model will be the best solution.
Okay, great. Thanks, Michael. Christian, some reflections on your side on this question here?
Yeah, it's a good question. Now, we have bought a company that is doing AI and machine learning and AI, you could say. And that's very good. It's good for a number of things. But I have to say one thing before going into this. AI is not the solution to everything around this. So there are elements. And also when we do the baseline, when we start with our models, we look at historical data. And we can't use what has been done of seed trials and shop tests in order to set the bar around that. And for any model that you use, any model-based approach, you need some baseline. And as Michael is rightfully saying, it's a matter of the data coming in. What is the data quality? What is our level of confidence around that data that is coming in that eventually will give us the results that we want to see? So any model is dependent on what data do you put into it. And we have also the struggle with working in the LNG segment where we are producing a boil of gas solution for the LNG owners. And that is fairly complex when we talk about the void and what we need to calculate, etc. And there it's even more important that we have the right data in there. So how do I rate it? I think it's good for one thing. And we are actually also using AI for some internal things as well, because it gives a quicker and faster overview. And you can actually see the outliers faster than if you start to build your own models. And probably the models that Sten has worked on in 09 with the bolt-on fleet, etc. You get a quicker insights on that, but be careful. Review the data quality, that control factors around that. That's the starting point.
Okay, super. Thanks a lot for that. Good reflection here. The same question for you, Ossie. How do you see this?
Oh, this is a very topical question. I was in 2 weeks ago in Tullamore, Ireland, taking part of this Halopic conference, and this was one of the key talking points there as well, and it seems to be the same trend elsewhere. I can nothing but agree with Michael and Christian here regarding the data quality. It's key driver for the AI and machine learning approaches, but also one of the shortcomings of the AI approach is the quantity of the data as well. So traditionally they require quite a lot of information, and unless you have high quality, high frequency data and a lot of that, the value might be diluted from these approaches. But definitely this space is moving so fast forward, it's hard to say where we are now compared to where we are going to be in 6 or 12 months from now. How I see this moving forward is mostly like combined hybrid models might be coming. So not so that replacing everything that we have now with the AI model, but rather using AI for data validation and quality checks, or replacing not the whole hydrodynamic model of the vessel, but rather focusing mainly, for example, on the machinery side, and then having the hydrodynamic model done the traditional way. And the other shortcoming of the AI is that they are black boxes. You cannot just open up the model and see what's in it, why they are producing the results they are doing. And that's a benefit of more these traditional models that they are. But definitely I'm a big fan of AI, and interesting to see where this space is going forward. And we are researching it a lot.
Thanks, Ossie. And I think this question here from this is somewhat similar, right? And it's spot on also discussion we have here. How reliable are machine learning models? And how often is it updated to reduce the differences between the model predictions and the reported power of fuel consumption? Sten, having worked with what initially was, starting from scratch and having a lot of manual data transferred from the fleet into the office, and starting to make some calls on what's the right thing to do. What are your learnings from this and your pitch in for this discussion specifically?
So to be honest, we never came to the level while I was managing the team to actually use machine learning. But of course, I've been looking at it on the side, and machine learning is an efficient way to improve your overall understanding of the data that you want to analyze. How often the actual model is aligned to the results. Actually, I don't know what the different suppliers or what kind of methods they are applying. So maybe we should pass that on to our guests. But
Yeah.
I would say machine learning is normally a loop where it will adjust itself regularly, if not almost continuously. That is my perception. I'm not the expert on the detailed machine learning, but I've seen some outputs that are quite impressive.
Thanks, Steen. We can take a round on that in terms of updates on machine learning. So how often do we adjust? But I would expect that it's an ongoing exercise almost, right? Ossie, you're nodding here. I mean, what's the frequency here?
I can, of course, comment on the frequency, but it, as you said, should be continuous. As we know, the performance of the vessel is always changing, hull fouling, machinery, wear and tear. All that does impact on the performance of the vessel, and a good model should reflect those changes. And it applies similarly to those traditional models that we discussed, but also the AI machine learning driven models.
Okay, cool. I'm going to jump to the next question here. I think there's a good one, and I may just take a portion out of this here because some of it might be a bit more on the obvious side, but I want to talk sensors and the hardware specifically because we've been through now each of you and saying you're flexible. You can work with different hardware providers. When we talk Danelec, there's also some in-house, quite a lot in-house capabilities within this front. So let's talk about the differences. I mean, again, we know data quality, right? But have we seen specifically examples from customers we work with where they've moved from, you could say, manual data to sensor data and the upside of doing that? Maybe this is a good question for you, Christian, to begin with.
Yeah, I think it's a super good question. I think if we take what I know quite well, the shaft power, then the sensors, everything that's related to what goes on around that is, of course, the power and the torque, etc. It gives you some clear indications on how much fuel you're consuming that can be used in that. So I think that's, of course, that's a given. That's a place where it's fairly simple to install and get going on. It's a little costly in the beginning, but it gives you insight fairly fast. For the voyage optimization, then it becomes more complex and perhaps somebody else should answer that. But there you have, of course, when you look at the optimal route to sail, and again, it comes back to also, as mentioned earlier, are you doing coastal trade? Are you doing spot trading? Do you need to range report at a certain time? Are you container liner? So again, there are so many variances in this question. I do want to say one thing, sensors at least give you the insight. And having an idea about an optimal route based on weather, etc., will give you a data point that can be used. But again, it comes back to the operators also making sure that they monitor that closely. One thing on the sensors, you can also see the sensor health and then see is anything drifting, is there anything that we need to be mindful of? And that will give you the insight that is needed to take action from the owner side.
Great. Okay. Thanks for that, Christian. I'm gonna jump a little bit, and I'm gonna pass it over to you, Michael. But I'm also gonna bring up a new question here, which I think is also really good from Nico. Linking back to the AI machine learning theme, does the panelists anticipate ship-side edge compute to take a larger role, using, for example, trained models to precondition sensor data? What are your thoughts here, Michael?
Well, I think there's a lot of, as also you referred to, there's a lot to gain from AI and studying sensor data. But I would say that I'm struggling with AI and machine learning because of the lack of time lag, where we are actually seeing we need quite a bit of data before a machine learning model could say something. And just going back to the example I had before, we had data for less than a day. We managed to inform the owner that the vessel was fouled, they could clean, and they actually saved quite a bit of fuel. I have not even taken into account what could have been saved in the optimization, the route optimization, was just the same route. But it's a machine learning model, and also you must correct me if I'm wrong, but you would more or less leave that voyage to happen before you can say anything about what was going on in the last port. And this is what we have seen with our system, that it's incredible the steps we see within the port stays. And you need to be able to react quick. And I'm coming back to the previous question. We need to get solid information, good, accurate information in order to take commercial and operational decisions. It cannot
Thanks.
be you get data that is a week old before, and then the opportunity is gone.
Yeah.
We need quick data.
So there's something around both amount of data and also the timing of data to make quick decisions on the spot. Ossie, reflections from your side here?
For the edge computing, it boils down to the value that we as an industry can provide for the on-board users. Of course, when we bring the calculations and all that computing to the onboard, the ship side, what's the benefit of that for the crew on board? I think the connectivity of the vessel is improving, the Starlinks and all that. The cloud infrastructure is also already quite mature in that sense. So at least for the near future, I'm not seeing that the edge computing is taking large leaps forward on that side, but I'm also happily proven wrong when that happens.
Okay, great. Thanks. So let's move away a bit from
Frederick,
yeah.
can I just comment on this one as well?
Of course.
Because we have an edge server as well, and we have actually 2 products that you can actually install. And we have, I think, 3,000 or 4,000 edge computers out there installed. So from my view, or from our view, product vision is here that, of course, what the operators are seeing on shore, the captains, the crew should be able to see same, and bringing an application on board, giving the possibility to have sort of looking into same view. It will also be easier for the 25-year-old operator to call the captain, who is perhaps sailed the world even before the operator was born, to convince about choosing the optimal route for sailing, etc. So I think there's a lot in this question, which I think is a very good question, where I think going forward, this will be the future, I think.
Cool. And thanks for that, because that actually leads into the next question. And we can take a round on this one as well. So this question here comes from Paolo. Any reflections on vessels, senior officers buy-in for these new tools? How is their decision-making process changing? Are we risking to have too heavy shore-controlled environments? So I think this plays very much aligned on this question here. I want to start with you, Steen. I mean, so in 2009, where you suddenly start to dive into the day-to-day performance of the vessels, maybe an initiative that had not really been happening to the extent before, at least for the new fleet coming in. So what was the feedback in terms of being somehow scrutinized and being asked to work much more on data accuracy and then work with the data and then optimize performance here? I mean, and the play between shore and offshore?
It's a very good question. And I'd like to say hi to Paolo, old friend. So what we experienced was quite positive adoption of all these performance measures on board. But we were also extremely active. We had 11 officer seminars a year for 3 years to really boost understanding for data quality, how we can help each other shore and ship to achieve these performance measures, to explain to the crew that, they need to focus on what they can do on board and kind of trust that the office personnel will focus on optimizing their end on arrival on time and so on. Because the element frustration that we did see was, why should we work so hard to save 3% when we are steaming fast to anchorage and then we wait 3 days before we go into terminal? So there was quite a communication part there. But when it comes to the new tools, when we introduced the vessel performance onboard analyzer, everybody was super, super excited because now they could see what they are actually delivering of data to the office. They're not just getting feedbacks on what to do better. They can actually see for themselves. And when we talked about voyage optimization tools that we were developing, they were just super excited and said, when can we have it? Because they don't see it as them not doing their job well enough. This is a tool in the toolbox to improve the efficiency of their work, just like they have all the other nice equipment on board. So the seafarers, they use the tools that they have and they like to have efficient tools. But these tools have to be designed in a way that are useful for the people on board the vessels. That's really important. So turn down the PhD level outputs and create actionables and clear understanding so that the crew can interpret and take action.
See, and I think I want to maybe just stay on that one and just take a quick round with the different solution providers here in terms of crew training required to actually utilize these tools and these systems that they suddenly get access to. I mean, what's required here? Is it cumbersome or is it intuitive? And maybe we'll start with you, Christian, and we'll take the round from the different providers here.
Yeah, just one comment on the other one here. I think at the end of the day, it is the captain who is responsible for maneuvering the vessel and keeping the safety for the crew, etc. So I think it's important also going forward that they are involved in the whole digitalization journey for our industry. Full stop on that one. Is it easy or difficult? We are using our customer success team to train and educate and continuously make sure that the operators and the users, technical managers know what they're looking at. We make sure that once we have new product features that we are involved, we try to co-develop with the customers to make sure that we're sort of on par in terms of what they want to see going forward and running workshops around that. So I would say if you spend some time in vessel performance, then it's fairly intuitive, but you can very quickly build something that is both complex and getting, as Steve is saying, to PhD or academia level where it needs to be toned down a little bit.
Cool. A good answer. I think I'll just highlight this question because it's spot on, and then I'll move over to you, Michael, for your reflections as well. Albert here is saying that AI machine learning is envisioned to improve and enhance better operations of vessels and environmental sustainability. The human-machine interface is an important element to consider how we're looking at training crew to measure up these advances, right? So if the spot on the topic that we're addressing here. Michael, from your perspective?
Yeah, first of all, for the previous question, I mean, for buy-in for crew, we actually have focused a lot to have the similar user interface on board the vessel as they have ashore when it comes to, for example, our charter party performance system. And I think we have actually got very positive feedback from the various captains because suddenly they don't have to evaluate the sea state or whatever. I mean, we present what is actually being measured and the crew on board as well as the operator ashore can see the same view and they don't need to discuss these numbers. That I think that's extremely important to get buy-in. And then secondly, we have also made quite a big effort to present our results in a view which is not so complicated. For example, the performance of the vessel is presented in one number, and that's the vessel technical index, which is live updated. So actually in our operational screen with live data, you can see what is the average over the last 3 months and what is actually on this current voyage you're on. So you don't need a high degree of understanding of performance in order to evaluate where you are.
Okay.
And that's extremely important to get buy-in.
Yeah, got it. Thanks. I keep on hearing, be careful of reaching the PhD level. That's not what we envisioned to get here. So some good reflections on that. I was supposed to bring that up also with Ossi, but I think maybe we lost him here. He was switching rooms, I could see. Thanks for that answer, Michael. So then I want to bring it into the future outlook here. So we've talked about various stages and continuous development of the different platforms. We talked about hardware versus software. And I think it's fair to say also what we see from Njord, there's definitely an uptake and an increasing interest in deploying some kind of vessel performance solution for your vessels. But what lies for the future? I mean, how will this develop 5 years from now? What does it look like? Either from your own perspective or from a more general industry perspective, vessel performance solutions or systems as such. Ossi, welcome back. I hope you heard the entire question here. Would you give the future outlook question a go?
Yes, sure. Sorry about that. I had a little hiccup with my laptop and dropped off for a second there. Just to quickly add on the previous question, which I didn't have a chance to comment on. We, of course, when speaking here in a webinar, we should never forget the seafarers that we have operating the vessels at sea. At Napa, we take great pride on the user interface and usability and ease of use from our solutions. And we have a customer success team helping our customers to take value from the product. So back to the future outlook, how I see that it's a few key topics that is improving. So one being the connectivity on board, which is enabling higher data transfer frequencies, but also better usability from the onboard users to the platform. And then in general, the awareness of the users is improving, partly driven by the regulations. So for the IMO 2050, that is pushing the need for vessel performance solutions, but also partly the fact that, to remain as a competitive shipping company, the operational efficiency should be in constant focus. And then, of course, the AI, we've touched that many times now, but especially on the next stage is data validation with AI seems to be a growing topic. But also breaking the silos between the solution providers. So the APIs are becoming more and more common.
Got it. Okay, across systems and across hardware solutions, etc. Okay, great. Thanks, Ossi. Michael, same question from your side. And we talked about the speed through water and this being something that is new. I mean, how do you see this in 5 years' time, and where are we then when it comes to vessel performance solutions?
I think as we see today, there's a lot of performance systems being developed, voyage optimization, performance systems, and so on. And I think we see a lot of them purely data driven and relying on what you say less accurate data. I actually see from Years Motion, I see there's a big opportunity for actually working also just as a data provider, where we actually provide weight data and speed through water accurately, which a lot of good solutions can use. Today, I actually see the solution is running a little bit ahead of the quality of the data. There's a lot of fancy stuff going on where you can do a lot, but if you do not have control of the accuracy of the data, I wonder what you get out of it. I'm not the one to say what you get out of it, but I think we see significant problems with data quality when we go on board many vessels.
Got it.
Therefore, I see from Years Motion, this could be a very big opportunity in the future to be able to provide solid data across the board to different providers of vessel performance.
Super. Thanks, Michael. And I like this notion or the statement around that the systems have actually surpassed the quality of data. And then that's a bit of a question mark because what are we then getting the most out of the systems that are being developed at the moment? Interesting perspective. Thanks. Christian, from your perspective, where are we? What's the future outlook?
I think the future outlook is that this will continue to grow as a market when we talk about which is good for both Glossy and myself, around the software analytics layer on top, and especially around the voyage, whether it's congestion routing or whether it's weather routing. And of course, the whole agenda around emissions that everybody knows in this room, and the opposite on Njord as well, is driving that. So there is pressure from all sides, whether you need to obtain financing for your vessel, whether you need to sell to IKEAs or Walmarts of the world, then you're asked, what is your ESG strategy, etc., and those kind of things. That pressure will for sure drive growth in this market and a demand from the owners to have something that is actually providing valuable insights and not high-level academia, PhD stuff. So I think that will for sure be one of the trends. I hope that the lack of standardization, the many different systems that you need to configure in order to get the data flowing, I hope that we at some point are getting to fewer of that, though, so we actually have a better data lake from the onshore to the onboard view and vice versa. So we get better, as Michael is mentioning, better data, better insights around that. I do think that the connectivity issues that we've had in the past will slowly disappear. over time and hopefully cater for that as well.
So less connectivity issues as well. Okay, great. Thanks. Thanks for the run through of that, Christian. We're slowly getting towards the end of this live event. I want to take a last round across all four. We'll start with you, Christian, then Michael, Austin, then and then with Steen. So the scenario here is this, right? What should you as a ship owner consider when you talk vessel performance systems? And so what I'm looking for is maybe just the quick elevator pitch. So when you walk in the door to a ship owner who has not started this journey yet, or maybe being in the early stages, what's your recommendation? What should we look at and why should you do it? So a quick elevator pitch of saying, is it relevant or not? And what should they consider when they start this journey? Christian, from your perspective, when you walk in the door here.
That's a good question, and it can be a very long answer here, Frederick. But
Elevator pitch, Christian.
yes, yeah, but that depends. Then I need to know who am I walking into? Because if I'm walking into where you're sitting with most tankers, we need to start the conversation in a different place because it's a sophisticated client. It's somebody who has been doing it for 30 years and has data capturing equipment on board. There, I need to start somewhere else because I need to replace something with what I'm coming with, and they're very advanced. If I go into a smaller ship owner with, let's say, 8 or 10 vessels, family business, they have done everything themselves. They know shipping. They have shipping in their blood for the last 200 years. So there's nothing that I can teach them around how to operate their vessels. There I need to do something different. And there I might not even talk about AI. I might talk about data quality and data capturing around that. But what I think is key in all the conversations that we're having is this an enabler to save fuel? Is this a way to be better equipped to do your emissions reporting? Yes or no? That is the starting point. Whether we then talk data capturing or whether we talk vessel performance software into that mix, that's where we start the conversation.
Okay, got it. Super good. I recognize it was a very broad question, difficult to answer, whatever. I also like asking those questions, but I get the point of saying, so what's the purpose? Why do we have this conversation around a vessel performance system? Is it to save fuel or is it for reporting purposes? And so it starts there. Thanks, Christian. Reflection from your side, Michael, on this same high level question?
I think that to be able to verify the performance of your vessel and have that on a, what should we say, more or less updated basis. That's where you can save quite a lot because that enables you to react. Normally, I say to people, instead of spending a lot of time and money on sort of a fuel saving device that might give you 1, 2, 3%, you should start to get control of your state of your hull and your propeller. There's a lot to save there. And this is where you can actually both save money and save the emission for vessels. And there's quite a bit to do there. And even the small owners, which has been operating the vessels for a long time, they all need that sort of information in order to make the best decisions. And there you can save quite a lot. Then the next step is when you're going to look at different fuel saving devices, which one are you going to adopt for your fleet? Then again, it's very important that you get solid data on which way to go. You cannot just take all of it. You need to select where do you get the best value for your money. And this is also something that vessel performance could provide.
Yes.
Yeah.
Got it. Thanks, Michael. So we've talked about some of the different things that you can apply on the vessel. Either it's wind assisted propulsion. We talked about fouling. We talked about keeping the propeller from fouling and energy saving devices related to that, and how we can use vessel performance systems either to identify the need for those ESDs installations or to validate them subsequently after installation. Thanks for highlighting that. Ossie, same question to you.
Yes, of course, I agree with Christian and Michael that the purpose should be validated, but also have to discuss on what's the appetite and capabilities of the company that I'm speaking with there. So are they still in level of reporting by an Excel? Are they Mask, who is basically having everything in-house and being very advanced on this space, or in somewhere in between? And at the time when I'm having this discussion is that the company would like to do the one big leap from nothing to complete solution of everything is solved and all that. That's of course one way of doing that, but especially for the smaller shipping companies mentioned by Christian with long history of shipping, but rather less on the performance analytics side. Is there some intermediate steps to take so that we can go through the journey of from zero to the complete solution of following the performance of your fleet?
Great. Thanks, Ossie. And I will conclude with a question for you, Sten. We have a long question here, and I'm not even sure that's fully complete, but it's just to link up again to Michael's statement around the return on investment. This is at least what one user is highlighting. Evaluating the return on investment is crucial to understand the effectiveness of what is implemented, and then conducting this independent assessment unbiased through analysis, and then derive at what is then these ESDs providing. And that's something that's necessary to conduct. Sten, from your perspective, walking into an owner, and I know again, different owners, different sizes, different journeys. What's your pitch or your say on vessel performance solutions when you have your dialogues with the different owners?
Well, basically, it's always technology number one that we bet, because creating transparency over the performance of the vessel is an absolute key for understanding how you can drive your business in the right direction. So transparency is key. To get the transparency, I believe we established earlier, data quality is super important. So it's about ensuring that quality sensors are on board, or that they will be included in the package. So we have as a minimum thrust meters, mass flow meters for fuel flow, speed through water sensor, and then high frequency data connection is definitely preferred. We try to pitch that very hard, because that is the future. Might as well get started. We have established that regulatory compliance, etc., is really helped a lot by having the high frequency data, so you can have a more accurate reporting, and also save some money there. Yeah, so quality sensors, a kind of high frequency performance solution, including some analytics, and then always remembering that you need to have somebody who can translate all those insights into actionables to actually gain the benefit. We normally say just by having high frequency data, there is % to be had, because the crew knows that their actions are visible, and they will change behavior to some extent, and that will create an improvement. And that improvement also includes just having the more accurate reported shifts the consumptions in a more positive way. So it's difficult to pinpoint exactly what, but you see better results. But real efficiency comes from using the data proactively to make decisions. And there it's important to either make the client understand that they might need help to do that, or they should build internal resources capable of doing that.
Super. Thanks, Sten. I think that was a good concluding remark here. That actually concludes our live event for today. I have the pleasure of trying to recap some of the key points here of the discussion today. I think we got a good introduction of the different systems out here on the call, the various journeys, the split between the hardware and the software solutions that you are providing. A very early stage conclusion we had was that, especially when you start linking in the hardware requirements and the data flow into it, it is a bit of a cumbersome exercise and it takes time. But I think what is also important to remember is then the benefits that you may derive at. We heard Sten's example of the 20% improvement from working rigorously with vessel performance in the early days with the Brostorm fleet. We heard Christian's example of a customer paper that has recently come out with a 20%, with the notion that includes many different enablers or levers pulled. We heard the example from Miros around the identification of a foul propeller, which came across super quick because of the high frequency data, and how that turned into a very specific 16% savings of that vessel for the voyage. And then we heard the flip or the add-on of weather routing combined with the wind assisted propulsion from Napa, where it took the 19% out of that, 10 percent points actually came from the system itself, and those insights that came from that system. So there's something tangible here. Some of the other concluding points I've noted is data quality and data accuracy is key. Again, I think there was super interesting notion coming across, saying that we may even see, I think there was you, Michael, saying that some of the systems out there being developed are a couple of steps in front of what the data quality is currently, which actually imposes a risk because it's the output of those systems then relevant to consider. We talked about having a right balance around the hardware, the different sensors to be deployed, and having a strategy around what is the minimum barriers of deploying specific sensors and hardware on the vessel to get the most out of the systems being deployed. We had a long discussion around AI and machine learning and the relevance of that. Again, it also comes down to the data accuracy that this AI is being built on, and also that it requires time. And the flip side is when you want quick insights into the performance of the vessel. And then we talked a lot about offshore and onshore collaboration. We need buy-in from the crew, one thing, and also the output should not be on the PhD level. It should be something that is easy to understand and easy to address and easy to action. And then we talked a bit about the future outlook for vessel performance solutions in general. We believe in higher frequency, better usability back to the less PhD level, and then increasing or ensuring that we use reliable data. So those are some of the points that I've taken note of here from our discussion as we went through. So that was the concluding remark. Thank you very much, gents, for your participation here on this live event. With the current interest, we've had a lot of sign-ups yet again today. We will naturally continue our live events. The next series will be in the month of June, where we'll continue to explore other efficiency technologies and trends in the market. In the meantime, feel free as the audience to go to our LinkedIn page, where you'll also find much more information, both the link to this session from today, but also the information around energy efficiency technology landscape and the work we do in Njord with ship owners and charters to accelerate their green transition journey accordingly. Again, huge thank you to the panel for your contribution. It was a pleasure to have you here today. And a big thank you to everyone who dialed in and for the questions you posted along the way. I hope the event proved useful and insightful, and stay tuned for our next event. Goodbye for now. See you.